than 1 that is not prime is called composite. So here the definition is given. However, without this definition also we should know that what are the prime numbers and what are composite numbers. Prime numbers are the numbers which have essentially two distinct factors, the first factor 1 and the second factor the number itself. So the prime numbers start from 2, 2, 3, 5, 7, 11, 13, 17, etc. And all the numbers which have greater than two factors are called composite numbers. So leaving 1 and all the prime numbers, all positive integers are composite numbers. For example, 4, then 6, 8, 9, 10, 12, 14, etc. Now, if the two-digit number n is greater than 20, that's one important information for us to answer the question. In fact, I am underlining all these informations because when we start solving the question, then many times it happens that the students miss the information. So it's really important for us to make it a habit to notice every single information given in the question stem itself. The question is asking, is an composite? So it's a question that requires the answer in the form of either yes or no. The statement is considered sufficient if it gives us unique answer, whether it's definitely yes or definitely no. And the statement would be insufficient if it gives us an answer in the form of sometimes yes and sometimes no. Knowing this fact, let's quickly look at the first statement and judge how useful it is. The first statement says that the tens digit of n. Alright, let me quickly explain. If I have a number A, B, C, D, then D is called the units place, C is called the tens place, B is called the hundreds place, and A is called the thousands place. That's only for sake of our understanding. So the question says the tens digit of n is a factor of unit digit of n. So the unit digit of number could be either 1, 2, 3, 4, 5, 6, 7, 8 and 9. Here I am not taking 0 because 0 does not have any factor. Now we have these 9 scenarios and the question says that the tens digit is a factor of the unit digit. So let's start with the first case. If the unit digit is 1, then 1 has only one factor, which is 1. But this is not acceptable because this is not greater than 20. So this case is out. Now, the cases which I have here with unit digit 2, 4, 6, 8. I'm not simplifying them further because we already know that they are composite numbers. That means they are giving answer to the question as definitely yes. Now, we have to look at only the cases where the unit digit is odd because we only have to check whether they are prime or they are also composite. So the case here when the unit digit is 3. 3 has two factors, 1 and 3. But the tens digit cannot be 1 because the number has to be greater than 20. So the unit place, for unit place 3, the tens place also has to be 3, which makes it composite, giving the answer yes. The next case is 5. When the unit digit is 5, then the factors of 5 are 1 and 5, but the tens digit cannot be 1 because the number is greater than 20. So the tens digit in this case can only be 5, which makes this number composite. 55 is a composite number, so answer to the question is still yes. In case of 7, again 7 also has two factors only, 1 and 7. We can't take 1 because the number has to be greater than 20, so we can only take 7 at tens place, which makes this number a composite number. So answer to the question is still yes. So there is no inconsistency that we have found so far. Now the last case is 9. With the unit digit 9, 9 has three factors, 1, 3 and 9. 1 can't be taken because the number has to be greater than 20. So either we can take it 3 or we can take it 9. If we take it 3, then the number becomes 39, which is composite. If I take the tens place as 9, then 99 is the number that we get, which also is composite. So there are two possibilities, but in both the cases the answer is yes. Now if you look at it carefully, you see that we have checked all cases and the answer is consistently yes. Since we have a consistent answer, so we failed to prove that it's not sufficient, and hence we are saying that the first statement alone is sufficient to answer the question, eliminating three options which are B, C and E. Now the answer choices which have the potential to be correct are only A and D, depending upon the possibility of second statement to be sufficient as well. Now let's quickly look at what does second statement give us. The second statement says that the tens digit of n is 2, while the unit digit the statement remains silent, which means for the unit digit 1, this number is composite, so answer to the question is yes. But for the same tens digit 2, the unit digit could also be 3, which is not composite, that's prime, so the answer to the question is no. That means it gives us inconsistent answer, and hence we can say that it's not sufficient to answer the question. Having said that, now we know that the answer to the question is going to be A option, because the first statement alone is sufficient while the second statement alone is not sufficient. I hope that helps. The most important part once again about the data sufficiency in my explanation is the ability to prove the statement not sufficient when we are saying it's not sufficient, and the ability to prove it sufficient when we are saying it is sufficient. Our intention should always be to prove it not sufficient, and that's why I put in so much effort to figure out if there was any inconsistent case. But in order to fail, in the case of failing to prove that it's not sufficient, I had to say that it's sufficient. I hope that helps, and this strategy is really helpful, especially for the data sufficiency question. Thank you so much for watching this video.